Penetrating WEP Security, Section 3. In this section, we're going to take a look at the fundamentals of WEP security. We're going to talk about how to set up a WEP access point, and then we're going to crack it 3 different ways. We're going to first crack it using AirCrackNG and Kali Linux, then we're going to crack WEP using Wi-Fi Pi, and thirdly, we're going to crack it using NetHunter on our Android device. WEP security. In this video, we're going to take a look at a brief history of WEP security. We're going to look at the theory behind how WEP security works, and we're going to point out the flaws in WEP security that we're going to use to exploit using our tools in this section. What is WEP? Well, WEP is Wired Equivalent Privacy. It was developed as part of the original 802.11 standard way back in 1997. That's 20 years ago. And it was designed to provide security for wireless networks. Now, the name implies that it's as secure as a wired network, but that's just not the case, even back in those days. But even back as far as 1997, they knew you had to have some sort of encryption to protect the data that was floating through the air, or bad guys would snatch it out and eavesdrop on it, which is exactly what we're going to do as part of our penetration testing in this course. Now, when you look at WEP, there was a couple of problems with it. The first one is that there was no peer review conducted. Normally, when you build an encryption algorithm, you want others to look at it because the security is in the key, not in the algorithm itself. But with WEP, it was developed kind of in isolation. There was no academic rigor, there was no peer review done. And so any vulnerabilities weren't able to be pointed out before implementation. The second big problem, though, is initialization vectors. Now, what is an initialization vector? Well, for WEP, we use RC4 encryption, and that takes a 40-bit key and is concocted with this 24-bit initialization vector. Now, the 24-bit initialization vector, it really is a key that we're going to use, and it is 24 bits long, which means 24 ones or zeros. Now, if you have 24 bits of zeros and ones, how many combinations can you have? Well, you can only have 16.7 million options, which back in 1997 may have taken a computer a long time to go through. But with modern computing, it doesn't take us long at all. In fact, on my computer, it takes less than about 5 minutes to break WEP because it can go through 16.7 million options that quickly. It's just not that secure anymore. Now, when we talk about WEP, we have to talk about the RIVES cipher because this is another big vulnerability for us. Back in the day, RC4, the RIVES cipher, was pretty secure, and it was being used to provide the confidentiality of the WEP algorithm. Now, CRC32, which is a cyclical redundancy check, provided the integrity of the data, and putting these two together, it allowed us to encrypt it with the stream cipher and create a checksum using CRC32 to provide integrity and confidentiality of our data. But again, that RC4 key is being used by that initialization vector, which makes it weak. Now, over time, WEP has evolved, and there are 3 different versions of WEP out there now. There's 64-bit WEP with a 40-bit key, which is the initial one that we talked about, the 40-bit with the 24-bit initialization vector. Then there's the 128-bit WEP with a 104-bit key, but again, it still uses that initialization vector, and 256-bit WEP with a 232-bit key. But again, it still uses a 24-bit initialization vector. Now, why do I keep saying it? Because that's what we're going to attack. We always go for the weakness, and in this, it's all about that 24-bit initialization vector. It's only 24 bits, which makes it really easy for us to crack. In fact, when we crack WEP, we can either go after the RC4, the CRC32, or the initialization vectors. In this course, we're going to go after the initialization vectors because that's the most common attack angle because it is the weakest point of WEP. So let's get cracking.